Okay, Assalamualaikum and a very good morning. So today we will enter a new chapter, mechanical wave. Okay, what is mechanical wave? Mechanical wave is a wave that needs to travel in a medium. Maksudnya, any types of mechanical wave kena ada medium untuk dia travel. The wave must have a medium. Examples of mechanical wave dekat sini adalah water wave, wave in rope, sound wave. So berdasarkan apa yang Miss bagi contoh dekat sini, you could assume the medium here dekat sini untuk water wave travel, medium dia adalah water. Untuk wave in a rope to travel, the medium here is the rope. Dan juga sound wave, the air here is the medium. Maksudnya kena ada medium untuk wave ini, gelombang ini untuk travel from one point to another point. Okay, apa beza mechanical wave dengan chapter 9, simple harmonic motion, di mana you also learn about a periodic oscillation. Betul tak? Apa beza antara dua ini adalah, in your chapter 9, you have, let's say for example, awak ada pendulum. Apa jadi adalah, you pull the pendulum to this particular point to the right, and then you release the pendulum. The pendulum is going to make an oscillation to the left, and then come back to the, and then dia akan come back to the right. And this periodic motion is going to produce you a sinusoidal wave. Okay, kita akan dapat wave juga. Cuma, apa dekat sini adalah, you have one particle, iaitu your pendulum is the only particle that is moving and making that oscillation. So, wave yang kita dapat dekat sini adalah due to that one particle, which is your pendulum. However, bila kita tengok chapter 10 ini, mechanical wave, tak kira lah water wave ke, wave in a rope ke, ataupun sound wave itself, the oscillation that produce the wave dekat sini adalah due to many particles. Maksudnya kita ada banyak sangat particles, dan semua particles yang wujud dalam medium itu akan menyebabkan the production of the wave. So for an example, kita ada water wave dekat sini. So ini adalah satu, this is your surface of your water. Sangat tenang. Okay, kita akan ada banyak molecule of your particles dekat sini. So kita akan ada molecule of water, kita akan ada molecule of water yang tengah duduk on the surface of water. So what is going to happen here adalah, when you drop a stone on the water, apa yang akan jadi adalah, the stone is going to disturb this one particle over here. So dia akan disturb kita punya molecule dekat sini. So bila dia dah disturb this one molecule dekat sini, apa yang akan jadi dekat molecule sini adalah, molecule ini akan turun ke bawah, at the same time dia akan ada vibration. So that particular vibration akan influence the particles dekat sebelah dia, molekul-molekul dekat sebelah dia untuk also vibrate. So all this vibration now is going to lead to the production of your wave. So kita akan form circular wavefront keluar daripada outward of the point of disturbance. So bila kita sambung semua circular wave ni, kamu akan dapat this beautiful nice wave ini. Okay, what is happening here adalah, the particles did not move. Okay, particle itu tidak bergerak. It's just that the particle, contoh yang kuning ni, dia start the motion di mana dia vibrate, dia akan causes vibration on the next particle, which leads to the production of wave. Maka kita pun akan dapatlah bentuk wave yang macam dekat gambar rajah yang ini, figure 1 ini. So what you have here adalah, kita ada wave, yang hitam ini adalah production of wave. Kenapa the wave has been produced here adalah disebabkan oleh you have particles. All the particles here is going to vibrate and produce a wave. Okay. So next kita nak tengok pada terminology, important terminology in this chapter 10, iaitu we have amplitude, which is the maximum displacement, sama saja macam dalam chapter 9. And then you have frequency, number of complete cycle that passes a given point per second. Di mana kita tahu frekuensi ni kita boleh dapat daripada equation of omega is equals to 2 pi f. And then you have period, time taken for the particles to complete one cycle of its oscillation, which you can also find using the equation omega is equals to 2 pi over t dekat sini. Alright? Ataupun you can relate your frequency and also your period, di mana your period here is equals to 1 over f and also vice versa. Okay, and then next you have wavelength. Okay, wavelength is a term that you are very familiar with. Cuma ini benda barulah untuk chapter ini. So you have wavelength, the distance between two successive identical points on a wave. Okay, so let's say kita ada, this is my wave, this is my wave. So distance between two successive identical point. Maksudnya kalau saya pilih titik saya sini, dari sini sampailah for me to come back here is one wavelength. Lambda kita panggil. Satu wavelength from two successive identical point. Contoh saya nak pilih titik sini pula sekarang. Sama pula. Contoh saya pilih titik sini. So what is going to happen dekat sini adalah this one here is my one cycle. Okay. Alright. And then next we have, this is another new term here dekat sini. Kita ada wave number. A wave number is the number of wavelength per unit distance. Is a number of wavelength per unit distance. Maksudnya kita nak tahu berapa banyak wavelength kita boleh produce dalam that particular distance. So equation untuk wave number dekat sini kita relate dengan a wavelength, iaitu 2 pi over lambda. So the unit here becomes m negative 1 as 2 pi tak ada unit, is unitless, and then wavelength kita unit dia adalah meter. Therefore your k has a unit of m negative 1. Alright. Okay. Next kita nak tengok bahagian progressive wave. Okay. As you can see, this mechanical wave yang saya cakap tadi, kita ada 3 jenis mechanical wave dekat sini, iaitu water wave, wave in rope dan juga sound wave ini. All these are a type of progressive wave. Progressive wave maksudnya the wave that is travelling. Dia wave yang boleh travel, yang akan travel. Ataupun dalam kata nama lain, dia adalah travelling wave. Okay, so you are going to have a new equation for your travelling wave, such as y in terms of x and t is equals to a sin omega t plus minus kx. Okay, before we look deeper into this equation, kita recall balik the equation in chapter 9 di mana you had y is equals to, you had x is equals to a sin omega t plus minus phi. This was your equation in your chapter 9 di mana x ni adalah displacement. And then the a here is the amplitude, maximum displacement kamu. Omega is the angular frequency and t is the time taken, ataupun kita nak tahu what is the position of your particles at that particular time. And phi dekat sini adalah your phase angle. Dia akan indicate where does your graph start at t is equals to 0. Dan ini selalunya adalah constant lah kan. So dalam chapter 10 pula, kita punya equation, kita guna y. Okay, we are going to use y. Dalam chapter 9, kita guna x in terms of t. Okay, tapi dalam chapter 10, kita akan guna y in terms of x dan juga t. So your y here is in terms of x and t, di mana your y here is the displacement now. Y yang akan jadi displacement, and this displacement, to be more specific, is known as the displacement of particle. Displacement of particle from the equilibrium point. Okay, it is from the equilibrium point. So let's say kalau saya ada wave dekat sini, let's say if I have a wave here, this is my wave, and this is my equilibrium point. Ini adalah equilibrium point saya. Okay, it is any displacement ke atas ataupun ke bawah from that particular equilibrium point. Alright, so we are talking about this y component as our y sebenarnya dekat sini. Okay, and then next kita punya x dekat sini. Apa jadi kepada x adalah distance of the particle from the origin. So maksudnya x ni adalah jarak partikel kita dah travel from the jarak partikel kita duduk from the origin. So let's say this is your origin, ini origin kita. So how far is that particle from the origin? Ini adalah x kita. So contoh, kalau kita berbalik ke graf ini, dekat atas ni, saya cakap we have many particles dekat sini, betul? Many particles dekat sini. And then let's say I want to know a particle, katakan particle ini, yang kita tengah cakap adalah this is the particle. Okay, this is the particle. Particle yang saya shade dekat sini. So particle sini sekarang dia tengah berada pada jarak x from the origin. This is what we call as the x tadi, distance of particle from origin. It can be any particle. Dia boleh jadi particle mana-mana pun. Katakan particle sini pun tak ada masalah. So ini adalah jarak dia daripada origin itu. Okay. Whereas bila kita cakap pasal what is that called? Y tadi, Y adalah distance moved by the particle from its equilibrium position. Initially, semua particles itu akan duduk along dekat sini. Dia duduk dekat sini. Macam dalam gambar rajah ini. Tapi disebabkan oleh disturbance on one particular point, dia akan vibrate, dia akan turun ke bawah, causes vibration, menyebabkan pergerakan pada setiap objek. That is why, objek yang, particles yang kuning ini, let's say saya panggil A dekat sini, dia, initially it was sitting on this particular point. Tapi sekarang due to that vibration, dia dah naik ke atas. Pergerakan dia adalah atas bawah saja sebab dia tengah vibrating. So this one becomes your Y, which is the distance moved by the particle from its equilibrium position. Sebab your particle is not going to move kiri kanan. Particle itu akan duduk dekat tempat yang sama, cuma dia vibrate atas bawah. That formation of atas bawah itu yang leads to the production of your wave. And then T dekat sini adalah at a particular time lah, time taken lah. And then we have next, kita ada dekat sini adalah A. A is still the amplitude, iaitu maximum displacement of your particle, which is going to sit on your Y component here. Ini adalah A kamu, dan juga negative A. Sin is the periodic motion ataupun sinusoidal wave formed by the wave. Omega dekat sini is still the angular frequency. And then K dekat sini is the wave number, yang terminologi yang baru kita belajar tadi. Wave number which has a unit of M negative 1 tadi. And as you can see dekat sini, your omega is related to the time and your wave number is related to the distance. Alright. And then kalau perasan dalam equation ni kita ada plus minus juga. Dalam chapter 10 ini, this plus minus has a meaning such as, kalau lah equation kita dia jadi Y is equals to A sin omega T plus KX. Okay, what does this plus here means? That your wave is travelling to the left. Maksudnya wave tengah travel ke kiri. Alright. Kalau lah dia adalah minus pula, what does this minus indicate here adalah the wave is travelling to the right. Okay. So plus minus dekat sini tengah indicate the direction of wave travelling ataupun the direction of wave propagates. Positive maksudnya ke kiri, negative maksudnya ke kanan. Okay, next we're going to look at the velocity for mechanical wave. There are two types of velocity for mechanical wave. One is particle vibrational velocity and another one is wave propagation velocity. Okay, what does these two velocity means are, when you have a wave being produced due to this mechanical wave, what is going to happen that this is the shape of your wave. Let's say I choose a point, which is indicating that we are choosing a particle. This particle is going to experience one velocity, which is known as velocity of the particle. The velocity is going to vibrate and it is going to produce particle, which we call as velocity of particle. At the same time, this particle and also the other particle that present in the wave is going to, that is present in the medium is going to produce the wave. Thus, the wave is also traveling and we are going to have velocity of the wave, which we call as wave's velocity. So there are actually two types of velocity. One is the particles and another one is the velocity. Your velocity of the particle moves in a direction such that up and down only, as it is going to vibrate up and down. And the velocity of your wave is traveling to the left or right depending on the direction of the wave travel. So, particles vibrational velocity is indirectly the velocity of the particle. Wave propagation velocity is the wave's velocity in a simple term. Okay, so the equation here is given as, for the particle's vibrational velocity is similar to what we have studied in chapter 9, which is we have two equations for velocity. One is with respect to time and also the distance of the particles. Another one is with respect to the displacement of the particle from the equilibrium point. So the first equation here is this one. V is equals to A omega cos omega t plus minus kx. And the next one is V is equals to plus minus omega square root A square minus y square. These are the equation for vibrational velocity of a particle. It depends on what information given. You can choose and use your equation. But usually we'll use the second one lah. It is very common to use the second one. Okay, if the question asks to find maximum velocity of the particles vibrational or particles vibration, the Vmax occur when the displacement is equals to 0, same as in chapter 9. So when your V maximum occurs at y is equals to 0, the equation now becomes Vmax is equals to plus minus omega square root a square minus 0 becomes a. So this is what we have for V maximum. And then next, for waves propagation velocity or waves velocity, we have equations such that V is equals to lambda over T, where lambda is the wavelength, T is the period. Or, as we know, T is equals to 1 over F, we can simplify the equation or produce another equation from that understanding, where F multiply lambda is also gives you the velocity here. Okay, you can choose, depends on the question what is given. If you have period, you can choose the first one. If you have frequency, you can choose the second one. Okay, let us now look at example 1 from your notes. So what we have here is a progressive wave is represented by the equation y is equals to 20 sine 20 pi t minus 0.5 pi x, where your y and x in meter and t is in second. Okay, before we answer the question and look at to the question, first thing is I'm going to compare my equation here, equation in the question with the with the general equation, which is y is equals to a sine omega t plus minus kx. So what I have here, I can compare from here, my a is 20, my omega here is 20 pi, my k here is 0.5 pi, and my wave has a negative direction here, which indicates that it is traveling to the right. Negative in the equation indicates that it is traveling to the right. So now I can write all the information I have, such as a is equals to 20 meter, and then omega is equals to 20 pi radian per second, and my k here is equals to 0.5 pi m negative 1. This is the unit for wave number, and then the wave is traveling to the right, as the equation has a negative sign. Okay, so now to answer the question, I'm going to read the question. We have the first question is to find the frequency. So the question asks to find frequency, and we know frequency can be found using the equation of omega, and we have omega in the question. We have already identified omega. And the next question B here, the question asks to find the amplitude, and we have also already found the amplitude by comparison. And then next, the question C asks to find lambda, which is the wavelength here. So lambda, you can find lambda using the equation of k, where you have k is equals to 2 pi over lambda. So you can find your lambda. K we have already managed to deduce here. And next, the question asks to find the period, t here. So once you have got your frequency, you can find your period. And then question E, the question asks to find velocity of wave. So this is the velocity of wave. According to the equation that we have looked previously for velocity, equation of wave is this particular equation here. So you can choose v wave is f lambda or lambda over t. Both the value you have got, frequency you have, period you have, wavelength you also already found in your question C. And then lastly, question F is the maximum velocity of the particle. So the question is asking the velocity of particle but the maximum. So we know V max occur when y is equals to 0. So you can use this equation, plus minus omega square root a square minus y, to find the maximum velocity of the particles. Okay, now I want you guys to attempt all these questions, do nicely and submit in GC. I've uploaded the a task for you people. So do your example 1 and upload your answer script in the Google Class. Okay, now we are going to proceed with displacement graph of a wave. Okay, so what happens here is we are also going to plot graph in this particular chapter for our equation. As I've mentioned in chapter 9, every graph that we sketch must have an equation. Maksudnya kena ada nama dia, betul tak? Baru kita boleh describe kawan tu. So for that particular thing, the same thing happens in your chapter 10. However, your equation for chapter 10 is y is in terms of x and t is equals to a sine omega t plus minus kx. Maksudnya, the value of your y is going to change according to your changes in x dan juga t. So, as x changes, the y changes. And as t changes, the y also changes. So, dia ada dua pun boleh ubah yang akan mengubah nilai y. Y depends literally on x and also t. So, for us to sketch, we cannot sketch y with respect to x and t together. Sekaligus tak boleh. So, kita akan split the graph into two parts, iaitu displacement versus time dan juga displacement versus distance. So, kita akan ada dua jenis sketching dekat sini bergantung kepada kita nak y itu in terms of x ataupun in terms of t. So, let's say if you were to sketch displacement versus time, maksudnya kita nak y versus t. So, apa yang akan jadi adalah, according to the question here, let's say you have y is equals to a sin omega t minus kx. So, kita nak y kita only to vary with respect to time. Okay, kita tak nak dia berubah dengan x. So, apa yang kita akan buat adalah, we are going to choose a value for your x. So, when you choose a value for your x, kita akan ada nilai, contoh let's say 0, pi, apa-apa sajalah nilai, and then you're going to substitute that particular value so that the x term here akan vanish. The term x vanish and it becomes a constant. Alright, so now let's say for an example, you have the question here, y is equals to a sin omega t minus kx, dan kita nak plot y versus t sahaja, maksudnya your y has to vary with t. So given that x is equals to 0, so we are going to substitute the value of x in the equation. Y is equals to a sin omega t minus k 0. So we'll end up with this one as 0. So your equation now becomes a sin omega t. So to sketch here, you have y with respect to t sahaja, dan we do not have any constant here. Tak ada plus minus phi. Maksudnya dalam equation ni kita tak ada plus minus phi. So you can simply sketch the graph such as, kita akan lukis paksi y, paksi x, paksi y, paksi x, where your y here is the y in which is the displacement, and your x-axis here becomes your time. Okay, so apa yang kita ada dekat sini adalah, you're going to first label your y as a, negative a. And then t dekat sini, as usual, one complete cycle, kita label dia sebagai period, and the shape of your graph is a sine graph. So you're going to plot a sine graph here. So kita dah dapat equation, graph for this particular equation. So this equation, dia punya graph dia adalah yang ini dekat sini. Okay, alright. Next adalah, let's say kita punya nilai x bukan kosong, tapi given as 0.25. So what is going to happen here adalah, kita akan tukar, substitute into the equation. Y now becomes a sin omega t minus k 0.25 pi. Okay, selalunya nilai omega, k dan juga a memang dia akan bagi dalam soalan lah. So at this particular point, sebab dia dalam general term, to simplify my kx ni, saya akan substitute my k with the constant dia ataupun with the equation dia, k with the equation dia, iaitu 2 pi over lambda. Ini adalah equation untuk k lah kan, 2 pi lambda. So saya cancel lambda sini, I will end up with a sin omega t minus 2 pi darab 0.25, I get 0.5 pi here, which means I have pi over 2. So as you can see now, equation saya is in terms of t sahaja. My y is going to vary with respect to t sahaja, sebab I do not have the term x. The term x has been substituted with a constant here. So untuk sekarang, bila kita nak sketch sekarang, kalau kita tengok equation kita sekarang ada omega t minus phi. Okay, so we have the value of phi sebanyak pi over 2 here, which indicates that dalam chapter 9 kita dah belajar, kalau ada phi maksudnya the graph changes the shape. Okay, maksudnya graph kita sekarang tidak akan mempunyai bentuk sine, dia punya shape dah ubah. Okay, and bila kita ada nilai V, kita kena cari where does your graph start when your t is equals to 0. Okay, so where is the position of y when your t is equals to 0? Okay, sebelum kita sketch, kita nak tentukan dulu. Okay, what are you going to do here adalah kita akan substitute y sama dengan A sin omega 0 minus pi over 2. Sebab kita tahu graf kita bukan bentuk sin, kita nak tahu apa bentuk dia. Oleh sebab itu, kita kena cari dulu bila t sama dengan kosong, apa kedudukan y. That is what we are trying to do here. Ni sama macam chapter 9. So, saya akan dapat A sin ini kosong minus pi over 2. Minus ni saya akan bawa ke depan. I will end up with negative A sin pi over 2. Sin pi over 2 is equals to 1 bila tekan calculator. Therefore, my y is equals to negative A. So, at t is equals to 0, my y is equals to negative A. So, sekarang I can start my sketching untuk equation yang berbunyi y is equals to A sin omega t minus pi over 2, iaitu equation ini bila x sama dengan 0.25 lambda. So, dia jadi gini sekarang. Alright, so now I'm going to sketch. Bila saya sketch, saya akan kena label dulu. This is my y, let's say in meter, t in second. I'm going to have my amplitude A, negative A, lepas tu 1 complete cycle period. Okay, masukkan nilai yang kita tahulah. So now to sketch, apa yang jadi adalah bila my t is equals to 0, saya punya y dah duduk dekat negative A. So this is where I'm going to start my graph. When t is equals to 0, my y is equals to negative A. So I'm going to start my graph from here. I'm going to complete 1 cycle. So dia kena naik, pergi ke maximum, dia akan datang balik sini. So this is the shape of my graph sekarang. This is how my graph looks like. Alright. So, begitu juga bila kita nak lukis displacement versus a distance. Tadi kita buat displacement versus time. Sekarang displacement versus distance. So, general equation kita adalah y sama dengan A sin omega t plus minus kx. Betul tak? So, sekarang kita nak y kita to vary with respect to x sahaja. With respect to x sahaja. We don't want with respect to t. Maksudnya kita nak hilangkan t lah. Macam tadilah. Tadi bila kita nak plot y versus t, kita make sure kita masukkan nilai untuk x supaya term x vanish and becomes a constant. So you're going to do the same thing when you want to plot y versus x. So kita nak y versus x, kita nak hilangkan, kita nak y versus x, so kita nak hilangkan term t, so kita akan letak a value for your t lah kan. So contoh dekat sini dia kata t sama dengan kosong, so the equation here becomes A sin omega 0 minus kx. So ini jadi kosong. So what you end up here is A sin negative kx. So bila negatif, saya akan bawa negatif ke depan. So equation ini menjadi negative A sin kx. So my y now is with respect to x sahaja. Tak ada term lain dan tak ada constant. So tak ada plus minus v dekat sini. So I can simply start my graph. So bila kita tahu tak ada plus minus v dekat sini, dia tak ubah bentuk graph lah. So kita boleh terus lukis, tak ada masalah. So bila nak lukis, I akan ada y meter. Okay, kali ni x axis saya adalah x sebab distance. Okay, katakan unit distance adalah dalam meter juga. So I'm going to label my amplitude, negative amplitude. Okay, bila kita plot y versus t, untuk paksi t ni, apa yang kita ada dekat sini adalah, contoh kita ada period. Okay, kita ada period. One complete cycle adalah period. Tapi bila kita plot y versus x pula, one complete cycle kita sekarang bukannya period, tapi dia adalah lambda, one lambda. Sebab kita tengah cakap pasal wavelength yang dia ada dekat sini. So ini akan jadi lambda. So pay attention dekat sini bila y versus x, dia punya paksi x tu kena masukkan nilai lambda. Awak kena carilah macam mana nak cari nilai lambda, dapatkan daripada k. K adalah 2 pi over lambda. Cari nilai lambda dekat situ. And then kita nak plot. So bila kita nak plot sign, tapi sign kita ada negative sign dekat sini. So you're going to plot a negative sign graph, turun ke bawah, naik ke atas, one complete cycle. Sorted. So ini adalah bentuk graf untuk equation y sama dengan negative A sin kx. So let's say sekarang kita punya t itu bukan kosong, tapi t ada nilai seperti 0.25. Sama juga, yang penting adalah the term T dalam equation kita is being vanished, substituted with a constant dekat sini. So omega 0.25 period minus kx dekat sini. Since omega dekat sini general, kita tak ada nilai, so saya nak masukkan nilai equation saya dekat sini. So this is becomes a sin 2 pi t darab dengan 0.25 period tolak kx, cancel my t here. 2 pi darab dengan 0.25, saya akan dapat a sin pi over 2 minus kx. Okey, dekat sini untuk cantikkan equation ini, kita akan rearrange supaya kx yang duduk dekat depan, constant duduk di belakang. So I'm going to rearrange this part here supaya my kx yang duduk dekat depan, constant duduk dekat belakang. So what is going to happen adalah a sin negative kx plus pi over 2. Saya rearrange sahaja. Okey, lepas rearrange, kita nak nampakkan lagi cantik, kita nak buang negative kx ni, kita nak bawa negative ni ke depan. So we are going to factorize the negative. So saya akan letak negative dekat depan. Sin, supaya my kx is positive. Bila saya factorize negative, maka dekat sini pun ada minus pi over 2. So my equation now becomes y is equals to negative a sin kx minus pi over 2. Di mana according to this graph, saya ada nilai constant iaitu phi. Angle saya ada phase angle. So for that, saya kena tahu, okay, so bila ada phi, maksudnya the shape of the graph changed. Dah berubah, bukan sin lagi. So kalau dia bukan sin, macam mana bentuk dia? Nak tahu macam mana nak lukis dia, kita kena tengok when t is equals to 0. Sorry, dalam kes ni bukan t when your x is equals to 0. I apologize. When your x is equals to 0. Kita nak tahu y kita berada dekat mana supaya kita boleh tahu bentuk graf kita dekat sini. So, what are you going to do adalah kita akan substitute y is equals to negative a sin k0 minus pi over 2. So, ini jadi kosong. So, negative a sin negative pi over 2. Bawa negatif ni ke depan. Becomes negative positive. Negatif positif lah kan. Bawa negatif ni ke depan. So, saya dapat positive a sin pi over 2. Sin pi over 2 nilai dia 1. So, y is equals to a. When your x is equals to 0, your y is at a. So, sekarang kita boleh lukis graf kita. Graf kita, y, letak unit dia. X, letak unit dia. Tulis amplitude dia. Untuk x, lambda dia. So, kita tahu kita nak lukis. Benda yang kita nak lukis adalah untuk equation yang ini. Iaitu y is equals to negative a sin kx minus pi over 2. Ini adalah equation kita. So for this particular equation, bentuk dia adalah bila your x is equals to 0, your y is already at a. So kita akan start lukisan kita daripada sini dan kita akan complete one cycle. So this is my shape of the graph for this particular equation. Are we good here? Okay ke semua? Okay, sebelum saya proceed ke example 2, saya nak tekankan balik. Kita akan lukis graf y is equals to a sin omega t plus minus kx. Kita ada dua jenis manipulated variables untuk y kita. Maksudnya bila t berubah, y akan berubah. X berubah, y pun akan berubah. So, oleh sebab itu, apa yang kita akan buat dekat sini adalah kita, untuk sketching, kita akan sketch y versus t, di mana you vanish ataupun you sub values for x so that y vary only with t. So, tempat x ni dah ada constant lah. Begitu juga when you want to plot y versus x, sub value for t so that y vary only with x. Okay. Another thing dekat sini adalah bila kita plot y versus t, this is your y versus t graph. Kita akan ada, let's say this is my shape of my graph. Apa graf ini tengah bagi tahu adalah we are talking about one particle. Kita tengah cakap pasal satu biji particle. Maksudnya berbalik ke bahagian depan atas ni, the first thing kita belajar dekat sini, let's say I choose a point. So katakan kita pilih particle ini. Kita pilih particle yang color pink ni sekarang. This is my particle now. Okay, what are we plotting adalah kita tengah plot Y versus T for this one biji particle. Okay, so apa yang kita buat? Partikel yang saya shade tadi tu, dia kan duduk dekat situ kan. So kita nak tahu with time. Bila T sama dengan 0 sampailah T sama dengan entahlah berapa banyak saat yang kita nak tu, macam mana bentuk partikel itu. Itu yang kita plot. Kita punya plotting Y versus T ini adalah for one particle only. Untuk satu biji partikel di mana position of the particle in term of Y, iaitu daripada equilibrium at a respective time. Tapi when you were to plot Y versus X dekat sini, Y versus X dekat sini, apa yang jadi dekat sini adalah kita tengah plot a graph for the whole particle. Maksudnya semua partikel itu, iaitu kita tengah plot graph of a wave. Maksudnya ini adalah a wave. Maksudnya bila contoh kita ambil yang case air tadi, awak drop pebble dalam air itu and that water is going to form wave. Betul tak? Wave yang kita dapat itu, itulah yang kita lukis dekat sini. Maksudnya semua partikel memainkan peranan untuk produce that particular wave. Cuma bila kita plot Y versus X ni, kita tetapkan masa kita. Nampak tak? Choose a value ataupun substitute a value for T. Maksudnya for this particular graph Y versus X ni, kita dah ada nilai T. T kita contoh 2 saat. So kita tengah lukis kedudukan kita punya particles untuk semua particles yang ada dekat situ pada 2 saat itu. So you're sketching for all the particles when T is equals to 2 second. Ini maksud graph Y versus X. So dapat beza tak graph Y versus T dan juga Y versus X ini? Kalau ada soalan bolehlah kamu nanti boleh buzz saya lah. So now we are going to look at example 2. Okay, dalam example 2 ni, what you have here is you have equation of Y is equals to phi sin 2 pi T minus pi over 2x. Where your X and Y are in centimeter and T is in second, dia cakap. Okay, kalau kamu perasan soalan 1 tu dia suruh determine amplitude, angular frequency, wavelength, period, frequency, wave speed, direction of the motion. Okay, yang ni semua kita dah discuss waktu example 1 tadi. Saya nak kamu buat sendiri lah, nanti kamu buat sendiri. Kamu compare dia dengan general equation A sin omega T plus minus kx. From here awak boleh tengok ini adalah A kamu, ini adalah omega kamu, ini adalah K kamu, and your graph has a negative here, maksudnya dia tengah travelling to the right. Okay, daripada comparison ni, awak boleh deduce lah jawapan untuk soalan A. Now I'm going to focus on the sketching part. Saya nak ajak kamu melukis, so saya nak pilih contoh dekat sini adalah contoh soalan C dekat sini. So untuk contoh soalan C, dia suruh sketch displacement versus distance, maksudnya Y versus X graph for the range of 0 less than equals to x less than equals to 2 pi, given that your T is equals to 0.25 period. Okay? Alright. Apa yang akan jadi dekat sini adalah, sebelum kita start lukis, kalau kamu perasan dekat soalan A tu, soalan A dah minta suruh kamu cari lambda, dah minta suruh kamu cari period semua. So lambda saya tengah ambil jawapan daripada bahagian A. Kamu kena calculate lah. Daripada situ saya dapat lambda is equals to, which is my wavelength adalah 4 cm. Dan juga period saya dekat sini adalah 1 second. So I'm going to reuse this information from question 1 nanti. Okay, so bila kita kena plot Y versus X, so kita kena remember nak plot Y versus X, Y can only vary with X sahaja. So T ni kita nak hilangkan, dia dah bagi nilai T sama dengan 0.25. So saya akan ambil equation saya, iaitu 5 sin 2 pi tempat T saya akan substitute value yang dia bagi 0.25 period. Period kita dah tahu nilai period adalah 1 second. Okay, nilai period adalah 1 second minus pi over 2x. So what I'm going to get here adalah 5 sin 2 pi darab dengan 0.25 adalah pi over 2 minus pi over 2x. So this is what I get here. Alright. So from here, untuk cantikkan dia, saya akan rearrange supaya x yang duduk dekat depan 5 sin negative pi over 2x plus pi over 2. Untuk mencantikkan dia lagi, saya nak bawa negatif ni ke depan. Factorize, I'm factorizing. Negative 5 sin pi over 2x minus pi over 2. So, berdasarkan equation yang saya ada sekarang, what happened here is, I have a phi. Bila saya ada phi, maksudnya saya tahu my graph has changed the shape. Bentuk saya bukan sine graph. So, maksudnya graph saya takkan mula macam ni. Alright? Untuk tentukan macam mana bentuk dia, untuk tentukan macam mana dia mula, I have to start with this deduction, assumption yang kita akan buat. Apa nilai y bila x saya adalah kosong? Kita nak cari yang itu dulu. So, for that, y is equals to negative 5 sin pi over 2, letak 0 minus pi over 2. Ini adalah untuk tentukan where does the graph start, sebab kita tahu dia tak obey sine graph dekat sini. Negative 5 sin, ini jadi kosong, minus pi over 2. I'm going to bring my negative here. So, negative become positive. 5 sin pi over 2. Sin pi over 2, tekan calculator dapat 1. 5 darab 1 dapat 5. So, my y is equals to 5 when my x is equals to 0. So, now for the equation of yang negative 5 sin pi over 2x minus pi over 2, bentuk graf dia adalah, kita akan lukis, x unit dia adalah sentimeter dalam soalan dia bagi, y unit dia pun adalah sentimeter. Okay, first kita akan label amplitude kita. Amplitude kita adalah 5, negatif 5. Untuk paksi x pula, sekarang dia adalah distance, so dia akan jadi lambda. Okay, dekat sini yang kita akan tengok balik soalan. Soalan ada bagi syarat. Okay, ini adalah bahagian syarat dia, iaitu dia suruh sketch for 0 is less than equals to x less than equals to 2 lambda. Maksudnya kita kena ada lukisan kita sampailah 2 kali lambda. Okay, selama ni kita lukis 1 lambda saja. So, sekarang kita nak 2 kali lambda sebab dia ada syarat 0 less than equals to x less than equals to 2 lambda. So, dia nak 2 cycle dekat sini, 2 wavelength dekat sini. Okay, so sekarang kita nak start sketching. So, lambda kita sebenarnya ada nilai, iaitu ambil daripada soalan 1 yang awak cari, iaitu 4 cm. So, what I'm going to do here is, saya akan masukkan 4 tu lah kan. So, saya akan dapat ini 4 cm, ini jadi 8 cm. So, now to sketch, my graph has changed shape daripada sine sebab presence of the phi sini. Saya tahu bila x is equals to 0, when x is equals to 0, my y is equals to 5. My y is equals to 5. So, saya akan start graph saya dari sini. So, dari sini saya akan lukis 1 complete cycle naik ke atas balik. Tapi sebab kita nak 2 wavelength, kita akan turun, kita akan naik atas balik. So, ini adalah bentuk graph saya sekarang. Awak lukis cantik-cantik lah. Alright, so this is the graph for this equation under this particular condition. Okay, so sekarang Miss nak kamu habiskan buat semua soalan dekat example 2, A, B, C, D dan E, complete everything. Submit sekali dengan example 1 tadi. So basically you have to do 5 example 1 to example 5. Buat semua ni, upload dekat GC. Saya ada letak due date dekat situ. Remember to submit in PDF. Okay, that's it for today.